Alright, today we're going to use the Pythagorean Theorem. And it's old news. Hopefully you remember that the Pythagorean Theorem is a squared plus b squared equals c squared, but now we're going to be adding one more step to it now that we know how to simplify radicals. So the Pythagorean Theorem, like I said, a squared plus b squared equals c squared. And the one that's important to us is the c. C is the hypotenuse, and if you're ever not sure which one's the hypotenuse, it's always the side that's across from the right angle. So in this case, our hypotenuse is the 10 because it's across from that right angle. And the hypotenuse is always the longest side. So when we set up a squared plus b squared equals c squared, we know that our c is 10. So c squared is going to be 10 squared. Now for a and b, it doesn't matter which one goes where. I'm going to start with x squared plus 6 squared equals 10 squared. Then we go through and we square everything. X squared is just x squared. 6 squared is 36, and 10 squared is 100. Alright, now from here, all we're trying to do is get x by itself. So to do that, our first step needs to be to subtract 36 from both sides. So to get rid of a plus 36, we subtract 36. So x squared equals 64. Alright, x is almost by itself, but we've got that squared. To get rid of a squared, we need to take the square root. They are inverse operations. So when I take the square root and the squared cancel each other out. When I take the square root of 64, I get that x equals 8. And then just to double check that it makes sense, 6, 8, and 10, those sides make sense for our right triangle. We know that 10 is still the longest side. Alright, so that's just a quick refresher. Now let's spice it up a little. Alright, new right triangle. Step number 1, which one is the hypotenuse, or our c? In this case, it's x. So it doesn't matter which one's a and which one's b. So I'll do 3 squared plus 6 squared equals x squared. Alright, 3 squared we know is 9. 6 squared is 36. X squared stays x squared. We have 9 plus 36 right here. I know it's hard to see. 9 plus 36 is 45. And then our last step to get rid of the squared is to take the square root. But here is where lies the problem. Because 45 is not a perfect square. If we take the square root of 45, we get a decimal. And before, when you use the Pythagorean Theorem, you probably did leave your answer as a decimal. But now that we know how to simplify radicals, we're actually going to simplify this. So we're going to do the factor tree. So two numbers that multiply to get 45. So the first two that came to my mind were 15 and 3. But yours doesn't have to look just like mine. 15 is 3 and 5. So we look at our 3 prime factors, and we notice that there are 2 3's. So the 3's buddy up. Remember, 1 has to die. So 1 3 escaped jail, and the 5 didn't have a buddy, so the 5 has to stay in jail. So our answer is 3 root 5. Alright, we're going to do just 2 more examples. The next triangle, to figure out which one's the hypotenuse, remember look across from the right angle, and this hypotenuse is 16. So C is 16 this time. It doesn't matter which place you put the x and which place you put the 8. And once you've got the equation, we're just going to solve it. So 8 squared is 64. X squared just stays x squared. And 16 squared is 256. So 16 times 16 is 256. Alright, in this case, to get the x by itself, we need to get rid of this plus 64. So we're going to subtract 64. So 256 minus 64 is 192. Last step, to get rid of the squared, we take the square root of both sides. And again, 192 is not a perfect square. It does not come out evenly. So I'm going to make a factor tray for 192, and I'm going to do it over here so that I have enough room, because 192 has a lot of prime factors. So I'm going to start with 2. 2 times 96. 96, I'm going to do 3 times 32, 4 times times 8, 2 times 2, 4 times 2. Like I said, a lot of factors, but we finally get all of the prime factors written over there. All right, so now let's look at what we've got. We've got 1, 2, 3, 4, 5, 6 2's, and 1 3. So 6 2's means that 3 of those escaped, but 3 of them died. Breaking out of jail is risky business. All right, so 3 2's escaped. 1 3 did not have a buddy. 3 2's make 8. 2 times 2 times 2 is 8. So our answer is 8 root 3. All right, one last example like this. So once again, we've got a right triangle, so we can use the Pythagorean Theorem. So 4 is across from the right angle, so that's our C. Well, what makes this look weird is 2 already has a root around it, so it looks a little messy. It's actually not going to make your life any harder at all. So I'm just going to plug it in, square root of 2 squared, just like I would any other number. All right, so we've got x squared. Now here's the cool thing. If it's already in a root like that, if I take square root of 2 and I square it, the square root of 2 times the square root of 2 is the square root of 4, which is 2. Basically, what happens is the square and the square root cancel each other out, and we're just left with 2. So we have x squared plus 2 equals 16, and we just continue to go. So we're going to subtract 2 from both sides. X squared equals 14. Take the square root. So 14 does not come out evenly, so we're going to make a factor tree for that. 14 is 2 times 7, and that's it. There are no buddies because 2 and 7 are not the same number. So our answer, we're just going to leave it as the square root of 14. And then that's it. That's our final answer. All right, so I'm going to make another video that explains how to use the converse of the Pythagorean theorem. But that's it for how to use the Pythagorean theorem. As a reminder about the Pythagorean theorem, whoops, I messed up.